Hello, this is going to be the recorded version of Lecture 9 since I will not be on campus on October 1st. So please check out the D2L site and the presentation, everything that goes with it, and we'll get through it. So the purpose of this lecture is basically to introduce you to the Bureau of Labor Statistics website and some of the reports. We're going to review some of the reports, and I'm going to introduce to you my no lost time to lost time ratio approach to suspecting under recording of injuries at a company, and it's only to suspect. So first, let's go to the Bureau of Labor Statistics. So I'm going to get rid of that. I'm going to open up. So here's the D12 page, except there will be a link for this video on here, of course, study sheet, and I've got some of the reports for you, but I want you to find it. Now, I already have it open here, but I'm going to open up a new web browser and type in www.bls.gov. And it'll give me the main page. This is the main page of the Bureau of Labor Statistics. And I want you to go up under subjects. And when you just go over it, it opens up this menu. And you want to go down to the center middle where it says workplace injuries. And it opens up to injuries, illnesses, and fatalities. And so it would be good if you could get familiar with this page and what's available here. You know, they've got publications, fact sheets, special releases about injury, illness, and fatalities, news releases, national data, all stuff that we're going to be getting into. Over here on the right, it'll give us the most recent survey data. So for the SOII report, which is the Survey of Occupational Injury and Illnesses, in 2013, that's the most recent report. The new one will come out probably in November or December of this year. There were over 3 million recordable cases in 2013. These were the number that were days away. Here's the median number of days away per case. Cases involving sprains, strains, and tears, this many. Cases involving injuries to the back, this many. And slip, strips, and falls. Below that, we've got the preliminary. That's what the P in the parentheses means. The preliminary report for the CFOI, which is the Census of Fatal Injury and Illnesses. In 2014, their initial estimates is that we had 40,679. That number will likely go up as they start verifying things. It typically goes up by a few hundred. Roadway accidents has been the primary cause of death on the job for years and years and years. It's been primary. We've got slip, strips, and falls at 793. We have homicides 403. So we'll look and see how that has changed over time and what that means. So let's see what we have here. Okay, so we've got non-fatal injury and illnesses by industry. Calculate your incidence rate, fatal injury counts, fatal injury charts, custom data. So that's stuff you can go directly to. There's also state data, so we could look at just Wisconsin. They've got some interesting stuff here. And then documentation. It gives you kind of the history of BLS if you haven't been here before. Handbook of methods for BLS and some other stuff. North American Industrial Classification System, something you should be familiar with. Here's the old Standard Industrial Classification Manual. The definitions for the CFOI and the SOII. And here's just some releases. So let's get into the reports. Let's see if we can find the so the fatality. Let's go news release. I really would like to find this in a PDF format. So this came out September 17th of 2015. Again, this is the preliminary report. I would really like to find the Adobe version of it. Let's see if we can find that. These are old. Wait. 917. Census. Final data. Really? I'm gonna go PDF right here. Yeah, there we go. This is what I wanted to show you. So, preliminary, it's 4,679. I believe that's what I just said. It's an increase of 2% from last year, or from 2013 rather. Let's try and find out. So it's still within, though, the realm of the rate per 100,000 full-time equivalency workers or equivalent workers. Let's see here. I'm going to try and see. So the final will be released in late spring of next year. Over the last 5 years, net increases of preliminary accounts averaged about 170. Like I said, a couple hundred, about a couple hundred. Low of 84 to a high of 245 over what it currently is. So it'll go up even more than the 2%. So this 3.3 per 100,000, it may run up to 3.4. It may tick up. So now they start giving us some key findings, and we can kind of see where the increases came. Fatal injuries in mining, 17%, agriculture 14, manufacturing up 9, construction up 6. That's interesting because construction has been increasing since the economic downturn in the US, and for it to go only up 6%, whereas 9, 14, and 17 in these other areas, that's actually very interesting. And then we go fatal work injuries for government workers, we're actually down 12%. That's interesting too. Slip, trips, and falls increased by 10%. Uh, Driven largely by increases in fall to lower level. Fatal work injuries involving workers of 55 age or over rose up some. Preliminary count, highest total ever reported. Interesting. Sharp decline. Fatal injuries in self-employed workers. Wait, after a sharp decline, it came back. So self-employed workers are up 10%. Women incurred 13% more fatality injuries. This is very interesting stuff. So, what's most interesting is the increase is not as high in construction. Where's where you'd think it would be? Because that tends to be one of our consistently more fatal industries. Excuse me. So you guys can look through this, and I want you to look through this because you're going to be commenting on this in your study sheet. Type of X, okay, fatal working transportation, we're slightly higher. Yeah, that's very slightly. Overall transport account for 40% of all fatal workplace injuries. Let's see here, fatal workplace injuries due to violence was lower with this much in 2014, so very slight again. Workplace homicides was about the same, but workplace suicides decreased. Interesting, by just 11. Let's see what else. Slip, trips, and falls. We're up 10%. Falls lower, we're 9% of it. So you guys can read this stuff, and you can find this in the 2013 report and just kind of compare how things have gone up and down. And this is a pure percent because it's a pie chart, but we can actually look at the percentages. They've got it by fire, by multiple incidents, by occupation. From a rate perspective, per 100 full-time equivalencies, logging is the most dangerous, but by a pure number, driver, sales workers, truck drivers is the most dangerous. So you get when you want to say what is the most fatal occupation or the most dangerous occupation, pure number says this, but by rate it means this. And I usually go by rate because it's per exposure. Whereas construction, oh, it doesn't have it by industry. This is by occupation. So let's see if they've got one by industry. Industry, construction had the greatest number, but we know it's gone down a little bit. But by a rate perspective, it's agriculture, forestry, fishing, and hunting. So you can read this stuff and kind of get some insight to where things have occurred from a fatality perspective. And when you look at this stuff over time, say if you were to look at this report for the last 5 years, you can start trending and really looking at the numbers. And so here's they've got it by they've got the 2013 and the 2014 here, so you can do it by, this is just raw number by event or exposure. Make sure you always read the table title to see what it is, and it would be interesting for you to do this. Here we've got it by fatal injuries, the number and percent. This is just 2014, and the selected event or exposure within the industry. Now they're not giving us the NAICS here. It's just sort of, categorically what is it. But you can see how these numbers tend to ebb and flow. But like here with goods producing, there are more fatalities from slip, trips, and falls than roadway, even though roadway overall has the greatest contributor. For private industry, it's still at top, but goods we goes the other way. For service providing, the roadway is in the lead. Let's see. Yeah, 'cause transportation's in there. What's this one here? So it's a continued list. Management occupations, slips, trips, and falls, jumps ahead. So you can for construction type stuff, slips, trips, and falls #1. So you can kind of see that depending on the industry you're looking at, what are the primary causes of death on the job, and that's what I want you to do to be able to look at it. Total, it's back up to 23. Is there any sway or difference here? When they're older, it's slips, trips, and falls versus roadway. Anything else interesting here? Yeah, I don't know. I just want you to look at it. Let's see. You could look at Wisconsin versus other states. The transportation's under this line. We had 16. It is a primary cause here. We had 26 in 2013 and 37. So ours went up. You can kind of look state by state. Look at West Virginia got more safe, which is interesting because what are the primary industries in West Virginia? Mining. But mining had an increase, yet they saw a decrease. There's a decrease. There's an increase in Washington, an increase in Texas. So it's just we can compare by state, we can compare by occupation, we can compare over time. It's just something that I want you to do. I just want to really quickly look at here and see what I want you to do. So I want you to look at the top 3 causes, top 3 industries. These are both from 2014, and now we're going to get into the SOI reports. Okay, so that's interesting. Interesting stuff we just reviewed. Let's see. Yeah, some of this stuff I'm finding for myself. This looks to be the report that I want. Yep, this is the SOI report. So this was published last December. It comes out anywhere from, between October and December typically. Sometimes they push it back depending on the amount of data and how many people they have working on it. So the overall incidence rate for everything was, this is just days away from work. I'm sorry, this is the wrong report. That's just, okay, that's not what I had wanted, but it was released back then, so I got tricked. Let's try this one. Employer reported workplace injuries 2013. Slightly more. 2013. Yeah, so 3.3 per 100 full-time. Yeah, that's the overall. But we can look in here. So total case incidence rate is TRC, total recordable case incidence rate. The DART will be just like we talked about in class. Here, see, they talk about a data error, and so that delayed things. That made things kind of weird for the 2011-2012. So somebody found an error in what was published, so they pulled everything, which made it very interesting for me to try to cover it. So here's the SOI. That's the report we're looking for. So look at, we can see since 2003 to 2013, which is this report, you can see the trend in the U.S. that it was up around 5 per 100. Now it's at 3.3. And then that's for total recordables. We can look at the DART, which is the red. And as you can see, we've had a somewhat leveling off since 2009, which is really when the economic downturn really hit. And that's, if we had unemployment on here, you'd see unemployment go up, and then it's been steadily going down. And so what numbers are responsible for this total? Because this represents everything, and this is individual. So we saw a 4-year plateau for the DART. Those are the days away restricted transfer cases, with a slight tick down in 2013. We had some of a consistent in other recordables. We had a sort of flat line on these other two as well. So we'll see what happens next year. If this DART is still at 1.7 or if it actually goes up to 1.8, it's going to be interesting to see. This is a chart that sorts it by size of company, and see smaller companies have lower incidence rates. Well, we know from the from the OSHA record keeping standard that if you have 10 or fewer employees through an entire year, you're not required to keep the log. And so this may be a somewhat limited sample, but in the ones who are submitting it, it's consistently lower. And so it begs the question, is it, does the size of the company somehow contribute to it? And for me, I believe that yeah, they can. It's easier to talk to each other. It's easier to assist each other. It's one-on-one, and people tend to know each other in small companies like that. And I think that contributes to a better safety environment. And here, basically they've got it by private industry, state government, local government. Local government is consistently higher, and state government is in second place, and then, well, except for right there, and then the lowest is private industry. And I believe this is because in honesty and reporting. Private industry, there's more motivation to under record things because there tends to be money involved in inspection. State and local governments aren't as bound to OSHA inspections or fear of reporting. So I believe it's more honesty in the reporting of injuries and not so much just it's less safe. Let's put it that way. By state, you can see that in the petrochemical industries in Texas and Louisiana, they're lying. To be that low, that's just unheard of. You'll have more honesty in the Midwest over here as well, and up here. So it's you take it for what it is. I can't see them being that low. They're lying. So now we're getting to the table one right here, incidence rates. This is something you're going to be using quite a bit in this class. So we've got the total case incidence rates in this column here. We've got this is the DART rate because it's cases with days away, restricted, and transfer, so DART. Here's the DART, and then this is like a breakdown within the DART, and then this is the other recordable cases. And if you'll recall from the OSHA log, total recordable, that'd be adding up all the columns. This would be adding up not the death column, but the days away and restricted transfer because here's they are. So I think it's like GHI, and J. So this is all GHI and J added up. This would be, if G is death, this would be H, and this would be I, and this would be J. And that's where that's the columns it represents, and then you put it into the incidence rate equation rather, and you come up with these numbers. And these are, what they do is they're surveying a sample from all these industries and then using statistics to extrapolate it to represent the individual industries. And we got the NAICS right here, North American Classification System code, and they do it in 2 and 3 digit increments. So all industries, including state and local government, we've got a 3.5. At the beginning, remember it said 3.3. Well, they're just talking about private industry. So at 3.5, it goes up a little bit when we include state and local government. We saw from that one chart why it would go up a little bit. The DART is 1.8 and the other is 1.7. With the private industry only, it's 1.7 DART and a 1.6 other recordable, which is going to become important soon. So I want you to be able to look through here and you can see the names of stuff, but you should also be able to use the NAICS. And I believe on here, I want you to actually look at historical records for all industries, including from 2009 to 2013. Um, I believe you could actually get that from that one chart right here. I think that, oh, this is just private industry. So it would be easy enough to look up. So let me show you how to find other things. So this is 20. Now there's one thing I need to show you because students get this wrong and then they get it wrong in the exam. And that is, I'm going to scroll down. I'm watching the NICS to where it kind of ends and restarts, which is right there. So it goes up to 813 and it's got state, local government, state government service providing. And then it kind of starts over. Now this is selected industries. Yeah. But this has something to do with, see, local governments here, and see, some of these industries here are local government or state government run agencies. And so we shouldn't take it from these bottom charts. Even okay, so that's table 2, but that was still table 1, even though it had gone from 813. So this is a completion of 1 down to these here, which are actually a different representation. And if we look at the footnotes for 5, excludes farms. But this has these numbers are a little bit higher, and so I think these are state and local government facilities that operate these things. That's the best I've been able to figure out because the numbers tend to be a little bit higher than the above or overall. And does it go to? It's kind of in a weird order too. but it doesn't clearly state what's going on. And so just be really careful to make sure you're staying up in the original table. That's what we're going to be using because it separates out the private industry from the local state government. And then when you get past it, I believe it includes it. So therefore it goes up. So be careful. And then we get down to 2, and it looks like it's private industry. Oh, look at it. It's a different numbers of injuries and illnesses, okay, in the thousands. So this is trying to estimate the number of count, and then they estimate the hours worked, and then that's how they calculate the incidence rate in the table 1. So I want to make sure that you, and this is a long report, it keeps going on and on, make sure you know what you're looking at when you're pulling a number off. That's my best recommendation that I have for you. Okay, so that's 2013 numbers. I want to find the 2012 numbers. Now, like I had said in class, they recently changed this website. So, lo and behold, they've kind of messed me up. That's not what I want. I know what I'm looking for when I find it. Yeah. They're just giving me definitions here. News releases. Let's see if this is it. So this is for fatality, non-fatal, industry counts. So that's 2013. Is that the one we had just looked at? Yep. And here's 2012. Yes. So see, this was published in November, so it kind of got pushed back. And so here is 2003 through 2012. Before is 2003 through 2000. See, I think the reason it's 2003 on because I think this is when they switched from SIC to NAICS. So there's some consistency in the trends now. Still lying. So that's 2012, and then 2011 is right here. That was published in October. Yeah, see, I was used to getting it a lot earlier in the year. Let's see what 2011 was published. Oh, maybe that's what I was just looking at. So that was October 2010 was also in October. Okay, so you're going to want to find these and pull off the information for 2009 through 2013 for all industries, including state and local government, because that one chart only shows for private industry. Then I want you to identify the industry and total case incidence rate in 2013 for NAICS 321. So I just want to help you do that real quick, and then I'm going to get into the no lost time, and finish the lecture. So let's go back to the most recent for the 2013. I'm going to scroll down to table 1. And what's that number again? 321. Probably did that. So 321 right here. It's wood product manufacturing 321. And the total case incidence rate is 6.4. The DART is 3.6. So the answer for that one would have been 6.4. Okay? And then I want you to get the DART for a different number that year. I wanted you to be able to find the incidence rates on these forms. That's the most important thing. So let's go back to here. So I've kind of given you a direct tour. Oh, it's already over 20 minutes. Ugh. I can go on and on. So I think we answered these questions. I want you to look through the reports. I want you to go to the Bureau of Labor Statistics and get comfortable with moving around through there. As you can see, they've changed it on me too, and so I can't say exactly where to find things. You just have to play around until you can find the reports you need. The incidence rates, we had looked at that as well. So what I want to get to is that there was a study published in 2006 in which they took this group out of Michigan took the BLS data for Michigan places and then compared to some of their state data because they had a different surveillance system. And what they found is They calculated that the current national surveillance system, which is the Bureau of Labor Statistics, did not include 61% and the capture recapture analysis up to 68% of the work-related injury and illnesses that occurred annually in Michigan. So what they're basically stating is, in just Michigan, say a sample of the overall, that what we're finding in BLS is only 39, no, wait, 32 to 39% of what really is occurring. So there's actually almost 3 times as many injuries occurring out in the real world than what the Bureau of Labor Statistics is showing us. So that's interesting. I guess I put it right down there. So why would employers underreport injuries? Well, we can talk about that, but really there's motivation to do that. They don't want to look bad. That you can kind of interpret 29 CFR 1904 record keeping standard to kind of force things not to be recorded, and also since their workers' compensation depends on what's occurring, they may attempt to reclassify or take care of certain incidents so there isn't a record of it, and then it doesn't affect their EMR as much. So if we're relying on the OSHA log data in order to calculate incidence rates to get a better understanding of the performance of our safety program, and we have things like workers not reporting things or employers trying to reclassify or treat an incident differently so it doesn't get recorded, um, how can we really trust what's going on? We're basically, if we're hiding too much, then our analysis is inhibited because we don't have the full sample of what's going on. So there's a way that we can evaluate if you want to call it the honesty of a company's record keeping by looking at it. We can refer back to Heinrich's pyramid. If we remember, for every 330 exposures, 300 resulted in near miss, 29 minor, 1 major. What we can do is we can use the Bureau of Labor Statistics data, the incidence rates, and break them down, or a company's OSHA log data, and kind of look at it that way. So of the 300 would not be recorded. That's near miss. So that wouldn't even be first aid. So that wouldn't even make it on the log. 29 is the other recordables. So we got 29 minor. These are things that are beyond first aid or first aid-ish. The 1 would be major, and so that would be our days away. That would be our restricted transfer cases. So if we were to look at a log or a version of the log, which I'm going to have to go back into our, let's go into lecture 8 and bring up this real quick. Of course, this is going to be my version of it. So F has been broken out here. So G is death, H is days away, I, J. So I always actually, I guessed that right. So anything that is H or I would be that 1. That's the major. So they got hurt so bad they couldn't go back to their original job, or he actually couldn't go back to work, or they died. So G, H, and I actually, but we tend to ignore that because it happens very infrequently, just for the data analysis purposes. For J, that is our minor, that's the 29, and then the 300 don't get recorded, unfortunately. So that's the way, that's the setup, rather, for this no lost time to lost time. So using Bureau of Labor Statistics data, we can actually look and see from an industry perspective how their record keeping is, or the honesty of their record keeping, if we assume that there is some form of ratio like this. So first we find the DART incidence rate. Second, we find the no lost time incidence rate, which is either the furthest column on the right or just the DART minus the total case. Actually, it's the total case minus the DART, excuse me. Then we compare the no lost time to DART ratio, which is no lost time to lost time, and how close it represents to things. So let's take a quick look at that in one of the reports. And let's see. So we've got, what year is this? This is 2013, and I'm right here at the top here. So what we'd look at, if it's for all things including state and local government, or whether you're just doing private industry, we take the DART versus, well, actually, it's the no loss time, which is this column here, other recordable, versus our DART. So here it's 1.7 to 1.8. So there are more there are more lost time than no lost time by zero point 0.1. So it's a fraction. And with private industry, we have the same trend that there are less no lost time to lost time. So, but if we were to kind of equate it to, it's basically 1 to 1. So that for every 10 cases that are recorded, 5 of them are no lost time and 5 of them are lost time. That's what this is basically saying. It's a 1 to 1 ratio. So in the case I just gave you, it'd be 5 to 5. Now let's go back to Heinrich, which he said it was 29 to 1. We're saying it's 1 to 1 now. So what people are reporting is that for every no lost time, they report a lost time, which means, if there's two incidents that are recordable, one of them is lost time, one is no lost time. That's the average. But then what we can do is we can look at it from an industry perspective. And, let's pick some of these industries. Mining, for instance. So they are zero point 0.7 to 1.3, which is almost a 1 to 2. So for every 3 incidents that are recordable, one of them is no lost time, 2 are lost time. And if we think of, when we look at incidence rates, we look at it from purely a number perspective. That a 1.8 is lower than a 2.4, therefore this must be a safer or less hazardous industry. But if we look at it from a ratio perspective, that based on the number, if for a particular number of exposures or recordable incidents, how many are actually lost time, so they're more severe, that is a new expression of not only possible under recordability, but also maybe it's more hazardous. So in this case, we have a 2 to 1. So then, out of let's give a common denominator. So out of 6 recordable cases overall, it would be 3 lost time, 3 no lost time. But in mining, it would be 4 to 2. Do you kind of see what I mean by that? Let's see. Let's try to find it. So under manufacturing, well, it's a little bit worse than overall. Let's see if there are any others that we can relate to. Retail trade, it is 1.7 to 2.1. Again, more lost time than no lost time. Transportation, oh, whoa, look at that. It's a little bit over 2 to 1. Or in no lost time, it'd be 1 to 2. Let's see, what else do we have here? Is there any that this number is greater than this number? Because that would mean that either it's less. Okay, so we've got right here, we've got a 0.6 to 0.3. So 2 to 1. So it's sort of the opposite of the ones we've already looked at. There's a 1 to 1. There's a 2 to 1. Let's see, what else do we have here? Now 263, that's the industry I did most of my research in. And as you can see, it's more dangerous than your average one. Not only from the ratio here, but its magnitude of incidence rates too. So there's several different ways now we can look at this data. And I want you to do that. Now, the reason that we can use these incidence rates as sort of a pure representation of no lost time to lost time is, let me just show you here quick on the page, and I hope that it's big enough that you can see. I'm going to make it kind of big here. So an incidence rate, let's call it an IR, is equal to the number of cases times by 200,000, and that's all divided by the number of hours worked, right? When we have an incidence rate, though, the number of cases is dictated by what we're trying to find out. The 200,000 is always the same, and if we're doing it within the same industry, it would be the same hours worked. So as you can see, this would cancel out both sides, this would cancel out both sides when we're comparing DART to the other recordable cases, just giving us the ratio of cases. And so that's why we can use incidence rate, or if we have logs, we can actually use the numbers that we add up, the sum of the columns, if you will, to get this no lost time to lost time. So that's the explanation, and it sort of gives a different look. And so I want you to kind of reflect on and think about this new metric, that this no lost time to lost time, and how if we're finding that there are more lost time than no lost time, does that mean it's more dangerous, or does that mean that they're finding they favor under recording or trying to not record the no loss times, which are much easier to not record just through a simple reclassification of what you're looking at. So here are some of my comments about it. That I don't think we should take this data at face value. I don't like the diluting of the data through both industry-wide but also just a company-wide incidence rate. I think we need to focus it on a job title or a cause. I think that's a better representation, because even with industry and overall industry numbers, there are going to be companies within there that are really bad players that would drive that number up, but then there are really good players that are driving it down. And there's honest reporting, but then there's data suppression. So there's a lot of variability or error in this data that I just don't think is being discussed. So what we're going to be doing next week is we're going to start reading the logs, and we're going to look at the entries and see what's there, and then we're going to bring in this data analysis and adding things up and calculating incidence rates and calculating no loss time to loss time ratios, and then plotting things over time and looking at trends over time, and then comparing it to other data and combining it for different forms of statistics, leading up to using percent frequency and percent severity to calculate risk priority numbers, and then we get very serious with what we're doing. So what I want you to do is spend some time at the Bureau of Labor Statistics. Spend some time reading those reports so that when I ask you on an exam or in class, what is the DART incidence rate for NAICS 263 in 2013, that you know where to find it and you know what it means too. Or what is the no loss time to loss time ratio for this industry this year? And you should be able to look that stuff up. And we'll be able to do it with a log, a sample OSHA log as well. So you can see how the company's doing, you can compare it to its industry from Bureau of Labor Statistics. It's all there. So I'm sorry this went so long, but work on this stuff, because we're going to be getting into data analysis next week, and things are going to move very, very fast. Thank you.